Hello everybody, and greetings from the Delta College Planetarium. My name is Brian, and I'm here to bring you the next episode in our series about the constellations. Last time we used the handle of the Big Dipper to find the bright star Arcturus and the constellation Boötes, the herdsman. This time we're going to extend that star hop to another spring constellation. Once again, we started the Big Dipper, which, during the spring, is high in the sky after sunset. The handle of the Big Dipper isn't straight, it's bent. Last time we imagined the curve of the handle to find the arc of a circle and followed that arc out to Arcturus. We're going to take this one step further. Imagine that curve is the swing of a hammer, and as it swings through that arc, it strikes a nail at Arcturus. That nail would travel straight from that strike and would spike down in a straight line to this bright star. This star also has an easy to remember name. It is Spica. You follow the arc of the handle to Arcturus, and then you spike to Spica. Spica is the brightest star in the constellation Virgo. Virgo is supposed to be a young girl in the night sky. Spica is meant to be a grain of wheat in her left hand. Above, to the right, this Y shape of stars forms the girl's head and outstretched right arm. To the left of Spica are the girl's legs. Spica appears blue-white to the eye. Compare this to the orange color that Arcturus appears, or the yellow of the sun, but you really shouldn't be looking directly at the sun. It can damage your eyes very badly. Where does that color come from, and why do stars have different colors? Consider other things that emit light, like an electric range, or an incandescent light bulb, or an iron bar in a blacksmith's forge. As the iron begins to heat up, it starts to glow a dull red color, and then an orange. If we keep heating it up, it gets to be yellow and then white hot. If you could keep going further, it would shift to more of a light blue color. Hot objects emit light, and the color of that light depends on the object's temperature. Blue light requires a lot more heat energy to emit than red light does. For things that are glowing hot, the cooler ones look red and the hotter ones look blue. When we see the stars, we're seeing their surfaces. The color tells us about the temperature of those surfaces. Arcturus is orange, it's redder than the sun, so its surface must be cooler. The sun's surface is about 5,500 degrees Celsius, whereas Arcturus' surface is about 4,000 degrees Celsius. Spica is blue, it must be hotter than the sun. Indeed, Spica's surface is nearly 25,000 degrees Celsius. We've discovered something about the stars. Blue stars are hot, and red stars are cool, comparatively. Between the arms of the Y-shaped portion of Virgo is a secret. A moderately sized telescope will reveal the presence of dozens of galaxies. This is the Virgo cluster. A 6-inch telescope will reveal about 160 galaxies in this region of the sky, but there are maybe 10 times as many in the entire Virgo cluster. The most famous of these is Messier 87. Other galaxies we've looked at in this series have been spiral galaxies, or disrupted spirals. This is the first elliptical galaxy. Elliptical galaxies don't have spiral arms, and they don't have bars. They just look like ellipsoid blobs of stars. M87 is about 55 million light-years away, far too distant to resolve individual stars. The points of light you see in this image from the Hubble Space Telescope are instead globular star clusters, each composed of something like 10,000 stars. A bright blue jet shoots out from the middle of the galaxy. This high-energy jet is powered by a supermassive black hole at the center of M87. Released in April of 2019, this is the first image of the black hole at the center of M87, and the first image of a black hole ever produced. It is the result of the cooperation of hundreds of scientists, dozens of institutions, and more than 20 countries around the world. The image is of radio wave light emitted by a disk of hot gas and plasma swirling around the black hole. The brighter parts of the image show where the disk is moving towards Earth at nearly the speed of light, and the dim areas are where it's moving away at nearly the speed of light. The black hole is about 40 billion kilometers across. It's about the size of Pluto's orbit around the Sun, lined up 3 times. It has the mass of 6.5 billion suns. So if it's clear where you are tonight, go out and find the Big Dipper. Follow the arc of the handle to Arcturus and then spike to Spica. Take a moment to consider what the color of all those stars is revealing about them, and think about that massive black hole in a far-off galaxy that you are among the first humans to ever see. That's it for today. Next time we'll take a look at another spring constellation. This is Brian from the Delta College Planetarium, wishing you clear skies.